Okay, so let me try to make some edits here. So I'm going to start with this paragraph describing figure 3. So let me go to the source. It says figure 3 shows the daily cost associated with each level of each of the 6 controls applied at 0 and 66% immunity respectively. All right, so this is shows here. Should be shows. Right. Okay, so let's see if this is an accurate description. Let's go down and look at the diagram. All right, so yes, for each level, you have the daily control cost here for the different controls. All right, so this is for 0% and for 66%. All right, let's see. And these are each of the 6 individual controls. All right, let's say each of the 6 individual controls because they're all separate. Let's see. All right, but it's not individual controls. Let's see. So each of the 6 controls, because you can't say the 6 controls because there are these testing, low risk, testing, and high risk are not the same as both testing, both distancing. Let's go back and see if this has been described enough. Maybe this is described previously. We can be for 6 different. All right, so instead of controls, you should say 6 different control strategies, because you've talked about these before as strategies. So you can't just say controls, you have to say control strategies. Okay. Here you say 6 strategies. So you can't say 6 controls because you can say that both testing involves 2 controls. So this should be 6 control strategies. The 6 control strategies. I say defined above, just to be with each level of. Here we don't need each of. Okay. And then you can say, and here you can say define above, and then you put a comma here. Applied at 0%, at 0 and 66. I think probably it's better to put here a percent also, respectively. Okay. On figure A, represented by solid curves, correspond to 6 strategies when all the population is susceptible, and figure B with dotted curves for population immunized at 66%. Now, this is saying the very same thing that is said in the first is in the first sentence. There's no new information here, so we should say this in the first sentence instead. I think we can simply combine these. This is for figure A. Okay. You can say figure. I don't think we need text-based boldface here, and 0% immunity and 66% immunity. This is figure B, respectively. Right, so this has no new information, so we can simply remove this. Okay. It says we notice that distancing cost for all population is higher than testing all population. So let's see what that causes here. Distancing cost for all population is higher than testing all population. Let's look and see what that means. So my question for this is, why are you pointing out this one particular thing? Why is this a critically important feature of this graph? When we look at this graph, what are the important features here? We can say that the 2 graphs look similar. What are the difference between the 2 graphs? Well, the difference between the 2 graphs is that both testing reduces here. The testing curves become quite a bit lower. I think that's right. This one is both testing, So that becomes lower. This one's testing low risk becomes lower. And this testing high risk also becomes lower. So I think that's that's one important thing, that the testing costs become relatively lower than the distancing costs. The distancing costs are almost the same for both graphs, but the testing costs reduce quite a bit. The other thing you can say is that for all of the testing costs, they are lower than the corresponding distancing costs. Here, testing for both is lower than distancing for both. Here, testing for low risk, which is where? Testing for low risk is blue. That's lower than distancing for low risk. Testing for high risk is lower than distancing for high risk. So, and that's true over here also, that the distancing cost, that the so the testing cost for the distancing for both is higher than the testing for both. So we can say that. So we should say something like that instead of just the cost for all population. We should notice. Okay. So you can say distancing costs are consistently, that cost per, okay. We can say costs for distancing are consistently higher than corresponding cost for testing. Okay, say for example, distancing cost for the entire population which is the most expensive strategy for a given control level, is higher than testing, than the cost for testing the entire population. Entire population at the same level of control. Okay, and then comparing the two graphs, comparing figures A and B, we see that testing costs, that distancing costs, do not depend on immunity level, but testing costs are greatly reduced. And how much are they reduced? Reduced by half. So even reduced by more than half. Okay, are reduced by more than 50%. By more than 50%. Okay. When immunity is increased from 0% to 66%. Okay. All right. So I think that summarizes that one. Okay. So we just need to make sure that we have described what the figure actually shows. You described what the figure actually shows. This is what both show. This shows A and B, and then here we give the interpretation. So always tell what the figure shows and then give the interpretation. All right, so let's go down and see the next part. All right, so here it says Figure 4 shows the cost effectiveness of 6 strategies in reducing RE. I think that what the figure shows should be described more clearly. What the figure also actually shows is reproduction number as a function of control cost, of daily control cost. So I think it would probably be better to say that. It does show cost effectiveness, but really better to say what it shows, what it's actually showing in terms of the quantities involved. Okay, okay, shows the dependence. Or show, okay, 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 shows, okay, okay. Uh, well, so okay. Let's say, let's see. Shows the costs, the daily costs, or shows the achieved, or let's just say it this way: RE level achieved. That can be achieved. That can be okay. Okay, we can say reduced RE level. That can be achieved. I'll just say via each of the 6 strategies. So as a function of daily cost. Okay. Well, actually, that's what. I'm sorry. I should have read carefully because that's what you say here. So I'll change this back. What you have originally is fine. Well, let's see. Maybe it would be good to combine both of these. I actually think that we can remove the first sentence. I think we can remove the okay. So I can say because you want to be very brief, if you can be. So in figure, as a function of let's say of daily cost. I'll call it implementation for the different strategies. Okay, where the cost for the different control strategies, where the control costs depend on the control levels through the relations here. Okay. At 0% immunity, the most cost-effective strategy is distancing applied to the entire population. This is true regardless of expenditure level. However, the situation changes at 66% immunity. In this case, testing of the entire population is most cost-effective. However, the effects of global testing are limited. Instead of global, I should say universal. And cannot reduce RE below 1 even at the highest cost levels. At the high, let's say, let's see. I should say in cost levels, control levels. Highest possible control level of testing. The highest possible testing level. Okay. Okay, as with figure these results do not account for the greater percentage of deaths among the high-risk population because they only include implementation costs and not the costs associated with hospitalization or death. All right, I think that's okay. Let's see if I like this. Let's see about this caption, if it's a good caption. Okay. Okay. Here I can say I'll say implementation cost. Let's just say that. So let's say daily implementation cost. Okay. Okay. Fine. Okay. Okay. I think we talked about this one before.